So the section I'm going to cover today is 5.5 in the book, and it's basically called special products. The first thing, I mentioned it in the last video, was the FOIL method. So basically the FOIL method is what we use. Sorry, excuse the dog if you can see her. It basically is what we use when we're multiplying two binomials. So FOIL method means we multiply the first terms, the outer terms, then the inner terms, and then the last terms. So this is just basically the steps that we go through, and then we add each of these steps together according to whatever signs are going on within the problem. So the first thing we do is we multiply the first terms. These two are the first terms, so 2x times x. Then we multiply the outer terms. So this and this are our outer terms, so plus 2x times 3. But this is a negative 3. Okay, so we got to make sure we keep this sign here. Alright, then the inner terms, which are these two here. So plus 5 times x. And the last two terms. Oops, wrong way in the arrow, there we go. Okay, so then that's plus 5 times a negative 3. And then all we do is we combine each of these. So 2x times x, remember when we add, or when we multiply two variables like this with exponents, we just write the variable and we add the exponents together, so that gives us 2x squared plus 2x times negative 3. Here we're going to multiply this constant and this coefficient, so we get negative 6x. Make sure we put it in parentheses. And we get plus 5 times x, that's just 5x, plus 5 times negative 3, which gives us negative 15. We do have two like terms in this expression, so we need to combine those like terms. A like term is any time when we have two variables that have the same exponent, same variable. So we combine negative 6x plus 5x. So when we combine those, we write our variable, and then we work with the coefficients. We add or subtract the coefficients. So negative 6 plus 5 gives us negative 1x plus 2x squared plus negative 15. And that's all there is to the FOIL method. You use this method anytime you multiply binomials together. So it makes it very simple. Okay, the next thing I want to cover is squaring a binomial. Alright, so you often will see something like this. So because there's two terms in here, it's called a binomial, and we have our 2 as the exponent, so it means we're squaring it. There's two ways to do this. You can either write it out using the FOIL method, or you could use a shortcut that we're going to go over. But basically, this is going to be just kind of like a definition or a proof. This is always a squared, that's right, plus 2ab plus b squared, or a squared minus 2ab plus b squared. Okay, so it's always going to follow this method. The first term is going to be squared, the last term is going to be squared. And the middle term is just going to be 2 this term times that term. So, for example, I'm going to just do a little problem here. Let's see. X plus 3 squared. So if we were to use this following one of these two, we see that it has the addition, so we know it's like this binomial. So we say, okay, we have first term squared plus 2 times first term times second term plus second term squared. And that's all that really is. All we have to do is just fix this now. So we have 2 times x times 3. This really becomes x squared plus 6x plus 3 squared. But now I need to square that, right? I've got to do that one. So that really becomes 9. If we were to do this using the FOIL method, it would be x squared, doing our first two terms here. Outer terms, x times 3 gives me 3x. Inner terms, 3 times x gives me 3x. And last terms, 3 times 3 gives me 9. When I combine 3x plus 3x, that gives me 6x. Both methods work. Both methods are correct. If your instructor wants you to show work, I would probably do the FOIL method because it does show that you know the steps better. But that's basically how it works. I'm going to do one that looks like the second demonstration here. 2x minus 5y squared. Okay, so it's going to look like this one. So 2x represents A, 5y it represents B. So we have first term squared, so 2x squared. Let's not forget to write the whole thing in parentheses, because if we had just written 2x squared, we're not really squaring the entire first term, we're only squaring the variable. So make sure that you're putting everything in parentheses, because you got to square the whole thing. Okay, minus, because that's what we're going to follow here, since there is subtraction in our binomial, minus 2 times first term, 2x, times second term. The minus is included in this second term here. Or we can, well, not necessarily, it's already out front. Ignore that. Just do the second term, because that's how it's supposed to work out. Alright, and then last term squared. So plus 5y whole thing squared. And then we just simplify it. We need to distribute this square to everything inside. When you have an exponent touching a parentheses, you distribute to everything inside the parentheses. So we get 4x squared minus, we have 2 times 2 times 5. That's 4 times 5 gives us 20 xy. Distribute this to both terms inside the parentheses. So we get 25y squared. That was really quick to go through, but I'm just trying to give you a quick little example of how to apply this. Normally, to do one like this, I would take probably 3, maybe 4 steps just to show my work and make sure that I'm not going to make any mistakes. I would combine these one at a time. I wouldn't just throw them all together. So go slower when you work these out and try and show some more steps. Just at least at first. Alright, and then what we have is called the product of the sum and difference of two terms. So basically that means whenever we have two binomials are like this. One is an addition, one is a subtraction, but the two terms in each of these are the same. For example, x plus 2, x minus 2. The first two terms are the same, they're both x. The second two terms are the same, they're both 2. The only difference is that one has addition in the binomial and the other one has subtraction. So whenever you have this, this is always just going to be, oh no, yes, okay, a minus b squared. And that's what it comes out to be. So you can know when you have a situation like this, it would just be x squared minus 4. Now, 4, because a is x, so we have a squared, first term squared, second term, b, is our 2. So it would be 2 squared, okay? But that becomes 4. So that's how I get x squared minus 4. You can still use the FOIL method with this also. So the FOIL method always works and trumps everything. These are just shortcuts to help you get through things quicker as things become more long-winded. But we can use the FOIL method. First terms, x times x. Outer terms, plus x times negative 2. Inner terms, 2 times x, and outer terms, plus 2 times negative 2. So we get x squared plus a negative 2x. I always like to write my coefficients in front. I think that's just more proper. And then 2 times negative 2 is going to be a negative 4. Remember, anytime we're multiplying or dividing positive and negative numbers, you just count the number of negative signs in your product or your quotient. If you have an even number of negative signs, then your answer is going to be positive. If you have an odd number of negative signs, your answer is going to be negative. I say that a lot because sometimes it's easy to forget it. Now we have two like terms, so we need to combine these. We also have a rule that any number, a being any number, except 0, when you add its positive and its negative, we always get 0, or its self and its opposite. So we have a negative 2x and a positive 2x, so it's going to give us 0. So our answer is just really x squared plus negative 4. Or you could rewrite this as x squared minus 4. That's basically all there is. It's just the special circumstances that happen with multiplying polynomials. So that's chapter 5.